You have a good memory, but you had a hard math exam. At the last minute, you didn't have time to relearn everything. So you memorized the final answers, just the right ones to pass the exam. That's caching. Instead of solving the problem from scratch each time, you already know the answer and save time. Hi, I am Sham, and in this series I will share behind the code insights, the deep thinking and system design that powers performance. Let's get started. Caching in memory is like your mother. She always knows where to find your lost blue t-shirt. Let's see how her brain works like a cache. Step by step. Layer 1. High-level application code. The moment you ask, "Where's my blue t-shirt?" she replies instantly, under the sofa next to the green pillow. Why? Because she has been asked this exact same question before, and she memorized it. As a key value pair, problem solved without even thinking. Let's see this Java example. We use the map with the key and the value of type string. The key represents the missing item, and the value, its location. Layer 2. Java virtual machine and runtime level. Her memory is now actively holding the information. She thinks, I remember updating that mental drawer when I saw him toss it after school. It's no longer a guess. She is recalling from her live memory. In Java, this hash map lives in heap memory. It's part of the running Java process. The object gets stored in memory, and the JVM references it using the key. Layer 3. Operating system and RAM level. She replied the moment clearly. I saw him change clothes in the living room. Blue t-shirt went under the pillow. This visual memory in her RAM, it happened recently and hasn't faded yet. So she recalls it instantly. No need to get up and look. What happens? When your app stores things in the memory, RAM, it avoids disk input-output, network requests, or recomputing things again. Layer 4. External cache layer, Redis or memcached. She thinks, even I forget, I have written it down in the family notebook. This is her external storage, not in her head anymore, but still fast to access. That's Redis. You still get the answer without a search mission. If you use Redis, the real-time data platform, you cache things outside your app, but still fast. How it works? Your app connects to Redis via TCP, sends a request to store or get data. Redis holds the data for you in its own memory. Layer 5. The final layer. CPU level caching. Before you even finish the question, she blurts, "It's under the sofa." That's reflex. Her mental L1 cache fired instantly. No thoughts, no visual memory, just pure muscle memory from being asked so many times. When code accesses the same data repeatedly, like looping over arrays, CPUs load data into their own tiny caches. If found, super fast. If not, fetch from RAM, which is slower. So again, when you lose your shirt, remember, your mom's brain and your computer are working hard behind the scenes, caching answers so you don't waste time searching. Also, you can't cache your data all the time, like dealing with frequently changing data, sensitive data like online checkout, or when caching ads, more complexity than benefit. Real learning happens when you try things at scale. Try caching in a real app. Cache API responses, like product list. Use hash maps for lookups. Explore Java caching libraries. See you in the next episode of Behind the Code and Low-Level Thinking.